Alright, so this video is being specially made for Ms. Shruti's class. We are going to cover two sections, or two lessons that we did in my geometry class. This is just to make sure that you guys are caught up, and then from now on, after this one, we will be on the same page. So geometric mean is what we're going to cover today, along with Pythagorean theorem. So let's get going on this warm-up, so the video doesn't take too long. Number one, we need to find the perimeter of triangle DEF if triangle ABC is similar to triangle DEF. AB is 6.3, DE is 15.75, and the perimeter of triangle ABC is 26.5. So, since we are dealing with just perimeter, we can set up a proportion, and since we have AB and DE, those are our corresponding sides of our two triangles, so we can set those up in one of our two ratios. So 6.3 over 15.75 equal to, now on the other ratio we're going to use the perimeters. So since we are given the perimeter of triangle ABC and the 6.3 is AB's length, then we're going to put the perimeter of ABC on the top. So 26.5 over the perimeter we don't have yet, we'll call X. So we're going to cross multiply. And when we do that, we get 6.3 times X is just 6.3X. And 26.5 times 15.75 gets us 417.375. Now we got one more step to get X all by itself and get our answer. That's going to be 2 divided by 6.3. Cancels on the left, and we're left with X being equal to, when you put that in the calculator, you get 66.25. We don't have any units, so we can just leave it as it is. So for number 2, again we're looking at perimeter. We have a figure JKLM, so that means it is a quadrilateral since there are 4 points to the name. Has a perimeter of 56 units. We want to look at the perimeter of the new figure after a dilation. So, our first step we should do is to list out what it means for the perimeter to be 56 units. First off, perimeter is just the sum of all the sides of a figure. So, all the sides for this figure would be JK plus KL plus LM plus MJ. Added together equal to 56. Then we're going to do this dilation, and a dilation means we're going to multiply each part by whatever the dilation factor, scale factor is. In this case, it's 2. So 2 times JK plus 2 times KL plus 2 times LM plus 2 times MJ. And that's going to be equal to our new perimeter we'll call P prime, since our new figure is J prime, K prime, L prime, M prime. So now if you notice, everything on the left side has a 2 in front of it, so we can factor that 2 out. So we have 2 times JK plus KL plus LM plus MJ equal to P prime. And now if you notice, everything inside that parentheses is the same as the left side of our first equation we wrote. So that means we can replace it with what it's equal to, 56. So 2 times 56 is our P prime. And now we just multiply those together, and P prime comes out to be 112. So let's take a look at our notes for the day. Got a couple of vocab words we're going to look at just today's notes. And those are geometric mean and Pythagorean triple. First off, geometric mean. The geometric mean of two positive numbers, a and b, is the number x such that a over x is equal to x over b. So when you cross multiply, x squared is equal to a times b, and x is equal to the square root of a times b. So, for example, the geometric mean of a equal 9 and b equal to 4 is 6, because 6 is equal to the square root of 9 times 4. 9 times 4 is 36. You square root that, you do get 6. So let's look at an example of that on our own. So this is in red. You need to write it down. So find the geometric mean between 2 and 50. So what we're going to do is do exactly that. We're going to use that formula we just looked at on the last slide. So x is equal to the square root of a times b. In our case here, a is 2 and b is 50. So just like whenever you, by the way, quick note, so this is geometric mean. When you think of mean in math, before now, the mean was always just adding all the numbers up, dividing by the amount of numbers there were, right? So that's what's known as the arithmetic mean. This is the geometric mean. It's a little different. So anyway, back to what we were doing. X is equal to the square root of 2 times 50. Plugging in our numbers we got. 2 times 50 is 100. And the square root, so a number times itself, is equal to 10. So 10 times 10 is 100. So now let's look at something to do with right triangles. That's what this whole unit is about. Right triangles and trigonometry. So, theorem 8.1 says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So, let's take a look at an example for this. Really, the best way to look at that is you can separate them out like they show here, where triangle ABC is being split into triangle ACD and CBD. I named those the way I did because the angles match up. So that's exactly how they have it written here too. Red ACD is similar to triangle ABC. A is the same angle both times. C for the red triangle is the next non-right angle, and B is that for the black triangle. And then same for D. D is the right angle, and C is the right angle for the black triangle. So you just have to match up, and that's what we're going to do for this next one. So write this and draw this on your paper. We are going to look at naming these three triangles, basically, and we're going to name them so that they are similar. So it means we have to make sure that the angles that match up for all three names. So we're going to start with the overall triangle. It's easy. Triangle GEF. Similar to triangle, now we're going to look at just the red triangle. So if we're looking at the red one, if you notice, G is in both the red triangle and the overall triangle, which means that's what we need to start with. They need to be in the same position. Then the next angle was the angle that's not the right angle, right? E is not a right angle, but F is for triangle GEF. But for the red triangle, F is the non-right angle. So that's our next one. And then H is our right angle. It's the only one left for this triangle. So there we go. You could have also started with G and then went to H, knowing that that was our right angle, and then F was the right angle for the overall triangle, and then just filled in the middle once you knew what your other two angles were going to be. Now, for our last triangle, we can start the same way we just did. Now, G is not in the blue triangle. We're looking at the blue one now. But E is in both the blue triangle and the overall triangle, and E was the second letter. So that means since E is not being split into two angles like F is, that's got to be our second angle. And in this case, H is again our right angle, so that means it's going to be last. So that leaves us for the blue triangle with F being the first angle mentioned. And that's our similarity statement. That's all we have to do. No numbers required here. So now we're going to take what we just did and what we did with geometric mean and put them together. So the geometric mean altitude theorem says the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of this altitude is the geometric mean between the lengths of these two segments. So in this case, h, our altitude, is equal to the square root of x, one of the segments of the hypotenuse, times y, the other segment of the hypotenuse. For the geometric mean leg theorem, the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments, same first sentence. The length of the leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So in this case, let's look at A first, right? A is one of the legs of the right triangle, the overall right triangle. C is the hypotenuse of it, and Y is the segment of the hypotenuse that is adjacent, so it goes to the same angle, B, right? Leg A and segment Y both form angle B. So that's why they are going to be together. So A is equal to Y times the overall length of the hypotenuse, C, or the square root of those two multiplied together. And the same goes for B. B is equal to the square root of X times C. So let's take a look at this. So here we have another triangle. We need to draw that and write down what we're going to find. Now for me, I look at it like the easiest thing we just looked at was the altitude to find, because there was no other math needed at this stage. So we're going to find E first. And E is equal to the square root of the two segments multiplied together of the hypotenuse, right? Two segments of the hypotenuse multiplied together. So JM and ML are the segments of the hypotenuse, and JM is 6, ML is 24, so we just multiply those together. 6 times 24. 6 times 24 comes out to be 144. And when we square root that, or we figure out what number multiplies by itself to get 144, E is equal to 12. So now we need to look at C and D. So C is one of our legs, and it is going to be equal to, now before we do anything, we need to know what the entire length of our hypotenuse is. So J to L just means we need to add the 6 plus 24, which gets us 30. So now that we have that, the segment of the hypotenuse adjacent to C is 24, and we multiply that by 30 inside of our square root. And 24 times 30 comes out to be 720. And the square root of 720 is not as pretty as the 12 we got for E. This is going to be 26.833. And that's not repeating, it just rounds to that point. Now we got to do D. Same process as we did with C. So we have JM there. That's the adjacent leg, or adjacent segment of the hypotenuse. So 6 times our whole length of the hypotenuse, 30. So now we multiply those together. We get 180. And we need to do the square root of 180, which again is not a nice, even, pretty number like E was. Ends up being 13.416. All right, so let's jump into our next problem. We have one problem left for geometric mean, and then we will be looking at the Pythagorean theorem and Pythagorean triples. So our next one is a more real-world type problem. Miss A, I don't know how to pronounce that name, so I'm just going to call her Miss A, is constructing a kite for her son. She has to arrange two support rods so that they are perpendicular. The shorter support is 27 inches long. If she has to place the short support 7.25 inches from one end of the long support in order to form two right triangles with the kite fabric, what is the length of the long support? So, before we even do any work to actually find our answer, let's take a look at this picture. So, we know that 27 inches is across both of our right triangles. And that means that it is also our altitude. So, I'll label our altitudes. So now the thing we're trying to find, the length of the long support, that is the hypotenuse of both of our right triangles. So that's this length here, which we already know part of as the 7.25. But we don't know all of it. We're missing this part I'll call x. So we need to find x, but we need to find a before we can find x. And once we find a, we can find x. Once we find x, we'll find L. Because we know two things. We know that our altitude, A, is equal to 27 divided by 2, because that's going to be split in half, which is 13.5. We also know that our L is equal to the 7.25 plus x that we don't know yet. And we know that our altitude, A, is equal to the square root of the 7.25 times x. Now, we know A, so we can plug that into the equation I just wrote and solve for x. So A, we just found, was 13.5. It's equal to the square root. I'm going to combine the two things together inside the square root, 7.25x. And now we need to get rid of this square root. And in order to do that, just like subtraction is the opposite of addition, the opposite of squaring is square rooting, and vice versa. The opposite of square rooting is squaring. So we're going to square both sides of this equal sign, of this equation. Cancel out the square root, and we'll be left with 13.5 squared, which comes out to be 182.25, equal to 7.25x. So now we just need to divide by 7.25. We'll cancel on the right, and we'll be left with x equal 182.25 divided by 7.25 comes out to be 25.138 when you round. Now we're going to take that and plug it into our L equation. So L is equal to 7.25 plus 25.138. And when we add these together, we get our final answer. L is equal to 32.388. And our unit here, we do have one, because it is a real thing, inches. All right, so now let's take a look at our next section. This is going to be all about Pythagorean theorem. You guys know about Pythagorean theorem, you've seen it before, but we're going to talk about both Pythagorean theorem and its converse, and we're also going to talk about Pythagorean triples. So, first off, Pythagorean theorem, hopefully you've already seen this before. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So that is very wordy to say that if triangle ABC is a right triangle with right angle C, then A squared plus B squared is equal to C squared. A squared plus B squared equals C squared. So we need to find X, which is our hypotenuse in this case. So we're looking for our C. So 4 and 7, the legs can be our A and B. It doesn't matter which one's which. So it's 4 squared is going to be plus 7 squared equal to X squared, our hypotenuse. And 4 squared is 16. 7 squared is 49. And we'll leave the X squared as it is for now. 16 plus 49 is 65. And just like I said before, the opposite of square rooting is squaring, so the opposite of squaring is square rooting. So we have to square root both sides. And since we are talking about a triangle, we don't have to include the plus or minus part of the square root. Because technically, we would have to if we weren't looking at a physical object. So a triangle has to have a positive length to its sides. So when we square root 65, our x comes out to be about, it's not actually equal to, so really what I should do is do a squiggle equal sign like that. and it comes out to be about 8.062. We have no units, so there's what x is. Here's our next one. This one's not the hypotenuse. We're now looking for one of our legs. So let's find our leg we're missing. So x squared plus the leg we do have, 8 squared, is equal to 12 squared. So what I like to do is go ahead and square things and then subtract. So x squared stays x squared, 8 squared is 64, and 12 squared is 144. We're going to subtract 64 from both sides. So x squared is equal to 80. And once again, last step is to square root both sides. And again, we don't want to include the negative. So x is equal to the square root of 80, which comes out to be 8.944. Again, I'm just rounding these. It doesn't tell us where to round to on these, so I'm just rounding to the third decimal place because that's what I like to do. Let's look at our next one. So these are Pythagorean triples. These are basically right triangles that come out with nice, even, pretty lengths for their sides. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now, you can take those and you can multiply them by the same number. So 3, 4, 5 times 2 each gets us 6, 8, 10. We multiply each number by 3. We'll get 9, 12, 15. That's what each of these numbers are below the top row of our table here. And then the last one there is just telling you that you can just multiply each one by the same thing and get another triple. It's just basically blowing up the triangle that you had initially, dilating it to be larger. So we need to use a Pythagorean triple to find x here. We have 26 as the hypotenuse and 24 as one of the legs. So let's go back to that table and look at which ones have a hypotenuse of 26. So if we look at the first column, we don't have any. Second column, there is one that has a 26 as the hypotenuse, the last number. And there is one that same one has 24 as one of the legs. So our other leg better be 10. So let's check and make sure that we get the same multiple out. So if we have 24 and 26, we can simplify these, right? They're both even. So we divide by 2, and we get 12 and 13. So if we wanted to, we could have used Pythagorean theorem this whole time, right? But we know that one of our Pythagorean triples means that the other leg is going to be 5. And now we just need to multiply that by 2 to get 10. The converse of the Pythagorean theorem basically just says the same thing, that if a squared plus b squared is equal to c squared, then triangle ABC is a right triangle. But there are some inequality theorems that go along with that. If c squared is less than a squared plus b squared, then the triangle is acute. And if c squared is greater than a squared plus b squared, then the triangle is obtuse. So let's classify some triangles. So here we have a 9, 12, 15. We need to classify this triangle as acute, right, or obtuse. So we're going to take the largest side, the 15, and square that. And we need to decide if it's going to be greater than, less than, or equal to the other two sides, 9 squared plus 12 squared. So 15 squared is 225, 9 squared is 81, and 12 squared is 144. And 81 plus 144 is 225. So they are equal, which means this is a right triangle. Okay, let's look at another one like that. So we need to determine if this is a right triangle. 10, 11, 13, or acute or obtuse. Sorry, just to figure out which one it is. So since 13 again is our largest angle, we start with that, our largest side, sorry. And then 10 squared and 11 squared. So 13 squared is 169, 10 squared is 100, and 11 squared is 121. 100 plus 121 is 221, which is greater than, so 169 is less than 221, and since that is our C is less than, or C squared is less than, sorry, that means this is an acute triangle. All right, so now let's move on to our next problem. Actually, I think this is for exit ticket. There you go. Do your exit ticket, and we'll see you next time.